Ever played The Sims before and wished the characters can say more than the preset responses? Imagine a Sims game except now powered by AI and the characters can chat with you more dynamically. Well, check out this game called PhiloAgents. It allows you to chat with characters that are famous philosophers, and the characters are powered by AI, so you won't get the same boring responses all the time. It's open source and part of a free course that teaches you the fundamentals of AI engineering by building a game. Today, I'm joined by Paul Iusztin, founder of Decoding ML, who partnered with NeuroMaze to bring this course to life. We're diving into AI agents, memory, and how you can create something amazing yourself. At the end, I'll give you step-by-step instructions on downloading PhiloAgents and making tweaks yourself so you can make it your own. Let's get started. Welcome, Paul. Great to have you here. Can you give a quick introduction about yourself?
Yeah, sure. I'm Paul Iusztin. I'm a senior AI engineer, content creator. I recently published the LLM Engineer's Handbook, a bestseller on Amazon. And currently I'm working at a stealth startup from San Francisco where we develop vertical AI agents as a service.
How did you get into AI and ML? How did you become an AI engineer?
During college, it just clicked. It was more of a gut feeling. For me, as I'm from Romania, there were no courses on AI. There was just one professor that pushed us into this direction, and he did some optional courses during the summer where he taught deep learning, computer vision, NLP, and all of that, which is actually what like LLMs are built on top of. I knew one thing in the beginning that I need to learn Python. So I just took the most Python heavy job that I could find during college. I had a chance to work in the domain where I picked up Python and building like backend, front-end mobile applications. And then I had the opportunity to jump into a machine learning, deep learning research position. I realized that research is not for me. I'm more of a builder than a scientist. I wanted to build stuff with AI.
You have your own blog called Decoding ML. What inspired you to start it?
I started it like 2 years ago. I started doing contracting work for companies abroad. While doing this contracting work, I realized that like the interviewing process is not in the advantage of the person who is interviewed because especially in this domain there's so many questions. Like as an engineer you need to know data science, machine learning, AI, data engineering, ML, like everything. You never know what you can
They're
be
gonna
asked,
ask,
right?
yeah.
Yeah, and in contracting work people don't care about lead code questions. You have to be very practical. I always love to learn, read, and try new things, but in those 30 minutes you have a limited time of questions. The match between what you know and what they ask is not in your advantage. So that's why I started pushing stuff on LinkedIn, on my blog. Initially, I had no intention to become a content creator, influencer, however you call it, but it slowly grew and I started like enjoying it more and more. And even so, now I still see myself as an engineer more than a content creator.
So that's the game you learned from contracting work. You have to push out content for people to be aware of you. So you're more proactive instead of playing the reactive game where they interview you and could ask you anything, right?
Yeah, exactly. That's very well put. After I started talking about my work, my interviews were just 30 minutes of getting to know each other. That's it. Because people are, okay, this guy knows what he does.
They already know
It doesn't
Paul.
matter. I think that having some sort of, not being a content creator, but some sort of online presence where you expose your work and you show that you actually have done something will be a huge advantage.
Now that we got a great background of you and we understand where you came from, how you ended up, kickstarting your career in AI and ML, can you tell us about PhiloAgents? I saw this game that's really cool. I would just love for you to tell us more about what is this course, who is it for, and maybe you can show us a little bit more in depth.
Yeah, my pleasure. I created a series of open source courses, and my latest one is called PhiloAgents, a collaboration with another content creator, Miguel Otero. We wanted to make something fun while getting into AI agents, AI engineering, and so on. So I think this is a beginner friendly course. That was our target. We wanted to show how you can integrate, for example, a agent built in LangGraph, hook it to a memory system, hook it to a RAG system, wrap it up into a API, hook it to a front end, and so on. Basically, what you do in a real job, but at a smaller scale. It really teaches all the core concepts you need around AI engineering in general. Maybe I can jump into a demo of the project and dive deeper. Is my screen?
Yeah, I see it.
Awesome. Because both of us are backend engineers, far from game engineers or engineers. We design like this 80s kind of game, which is kind of common in the AI agents world. Many papers mimic this 80s style UIs. It's a simple game. You just hit let's play, and as I said, we have this very basic interface where you have the main character and you can go and interact with different philosophers, right? So this is why it's called PhiloAgents. And instead of being like standard NPCs, which are usually coded in games until the rise of LLMs and all of that, these are real agents that you can interact with. So for example, you can just go and chat with them. And what's interesting is that we manage to, through prompt engineering, to like take characteristics of each character and try to make them sound, for example, like Socrates. And also we applied memory systems and RAG to like inject into them facts about their lives. So for example, if you ask him things such as you can check Wikipedia, you will see that this is true, right?
And for this, do they also get some memory about the players' conversations? Do they have memory of the whole conversation flow?
Yes. I will go a bit later in more detail, like what are some different types of memories. But yeah, it remembers, even if I chat with someone else, for example, with Ada, and hello, I am Paul. Let's talk with Nit and say that I'm Miguel. Okay, and let's now go back to Ada and let's say, who am I?
Yeah, that's awesome.
So basically, it's like a private chat. When you chat with everyone, is a private chat between me and them. And this technique is called threading. For every conversation, you allocate a thread ID, and in the short memory, you save a chat between a person and a chat bot, between multiple bots per thread ID. When I go back, it loads all the previous conversation into memory, and it will have all the necessary context to chat with us.
Gotcha. Well, that's really cool. Can you share a rough overview of PhiloAgents architecture and how it all works together so beginners can have a quick overview of what they're going to learn?
Yeah, my pleasure. That's my favorite part. I will begin with this high-level architecture. Maybe I can even zoom in into one. Yeah, I think this is better. So the core idea, so this is, as I said, like the high-level system diagram of the PhiloAgents project. So what you have seen is only the game, which is like, as you can see, the smallest piece of the system, where basically we just make HTTP requests to a FastAPI server, which hosts our AI agents logic. So this is a standard front-end, back-end architecture used almost everywhere. This is a common pattern on the web. So every time you make a chat call, so every time you go and start and enter a question, yeah, but for every question, an HTTP request is made to the FastAPI server, the AI agent is called, and it returns your answer in real time, because we use WebSockets to create like a open connection between you and the servers. So every time, instead of waiting for the whole answer, you get this token by token, word by word generation, similar to what you see in ChatGPT or other chatbots. You never wait for the whole answer. You just see how it is generated. You see see it word by word. Let me bounce between this and the diagram. So we have this chat HTTP endpoint. So when we call that endpoint, we actually, under the hood in the Python code, we call the AI agent, right? The AI agent implementation, which in our case is implemented in LangGraph, which allows us to create all sorts of AI agents. So it's a specific framework for that, but I'm not that articulate about using LangGraph. You can build it from scratch or use other framework. But the idea is that within the Python code, we call the AI agent layer, which under the hood uses smaller components, which are related to memory, prompt engineering, and the actual LLM API calls that we make. So basically in the AI agent layer, we have this LLM API layer, which allows us to, for example, call Grok in our specific use case, but you can also like leverage any other LLM API like OpenAI, Anthropic, or Gemini. We also have the prompt management layer built inside this agentic layer where we do all our prompt engineering in our specific use case. We have the system prompts where we do this impersonation per character. So we have our prompts over here. So we have this philosopher card where for every philosopher name, we have like a different perspective and talking style, which is created dynamically on every call. And also we have the state client and retriever tool. The state client helps us keep the short-term memory intact. As you saw in the game, when you jump between character to character, they remember all conversation. And even if we reset the game, I just resetted the game and let's play and go back to Ella Love, ask her, who am I? It remembers because all our conversations are persisted, in this case in MongoDB, and when we enter the game, they are retrieved. And because we have a different thread ID, a unique identifier for each conversation between me and a specific agent, it knows to separate conversation threads. And the long-term memory is where we do RAG and we know like facts about each character. So we know where Socrates were born, his works, what some of, I don't know, life challenges and everything basically that you can find on Wikipedia and on the internet in general. So one key component of these systems, which is like different from classic software engineering, is building an observability pipeline, which basically tracks all the conversations that you're doing with a philosopher into like a specialized UI and lets you monitor all your conversations, all your conversation threads, and evaluate them. This LLM evaluation is more tricky. So I will start now with LLM evaluation and I will move on to prompt monitoring afterwards. Maybe I can even show you what this topic. But on LLM evaluation, it's trickier to evaluate these systems and write tests, classic tests, to see that your system is working. Because when you chat with a character, many answers will be valid. For example, you can ask where she was born or her work, and she can answer in an infinite number of ways, which are correct. And I don't mean like the key facts, like the city or the date, like the sentence itself on how it's formulated, what words does it use, and what's the grammar and all of that. So it can take very many forms and it's still correct. And that's why you need like specialized techniques to extract the core essence of the answer and check only that if it's correct. And that's why you usually need to use like LLM as judges is called, where you basically use another LLM to check a reference.
Whether that makes sense.
Yeah, between a reference answer and the answer, which is usually generated by humans or reviewed by humans, and the answer generated by your application. And this is how you can write unit or integration tests for your system. This use case, we showed how to generate an evaluation data set automatically between you and each character, because each is different. Then you can review it as a human to see if it's okay, and you basically created evaluation data set, which again is not that easy to create from scratch, because you want to see how the system behaves on multiple conversation turns. For each character, for each use case, like you want to have 2-3 question and answers and see how the conversation is going. This is regarding evaluation. Let me show you how the topic looks. Let me log into it. One sec.
So OPIC, is it open source?
Yeah, it's open source, so you can host it yourself. They also have their own self-hosted version of it.
Gotcha. So for OPIC's main job is like LLM evaluation. Basically, it's like a test platform for LLM specifically.
So it's mostly, if people are coming from data science, is like experiment tracker adapted to this LLM world. It has evaluation, but it started from monitoring. You cannot use standard monitoring system like log systems to monitor these applications because usually you have complex conversations that are going on. When you call an agent, that agent itself usually makes multiple LLM calls or calls to a database, and there are many complex steps happening behind the scenes. Every step has multiple questions, answers, context. Very hard to track using normal logging systems. For example, this is our latest question where we try to hijack the agent. This was the input question. We have this trace. It logs everything happening behind the scenes inside the agent. We have multiple events happening. We can see the latency of each step and the cost for each LLM call. Most importantly, we can see the input with all the metadata. For example, for ad relevance, we can see the perspective, the style, and all of this, and the output. And not only the last output, we can, for example, see the whole memory, right? So this is like basically the whole conversation thread that is saved behind the scenes with metadata like usage tokens and all of that. And we
I
can
see.
start digging even deeper into this and, for example, see, okay, how was the LLM call made to Grok? What does it contain? What's the system prompt sent to Grok its output? Because what we enter in the UI
Yeah.
until it hits the Grok API,
Yeah.
there a lot of things are happening in between. So you need to track all these steps.
Why do you need Grok and OpenAI's API? Why not just use Grok? Why do you need OpenAI's API still?
So that's a really good question. So basically, when we developed this course, OPIC was working just with OpenAI models for the evaluation
Oh.
part that I said earlier. But in
Mm.
reality, you don't really need both. You could have
Mm.
done everything just with Grok. But usually, when you run evaluation with LLMs judges, is good practice to use a different model and a bigger model to evaluate
Oh.
your system, because you want a model that's more capable to say that your answer are good or bad, right? It is similar
Oh.
to, okay, you go with your homework to a peer from your class to say if it's okay, or you go to your teacher to see if it's okay. So that's
Mm.
why you need a more powerful model to check that your answer is okay. And usually OpenAI or other giants usually have these models available.
Oh, I see. Gotcha. That's good to know about this best practice.
Also, the best part that you can do is to use the same model to evaluate your system, because usually the model likes its own answers and will say that its own answers are good. So
Mm.
even if you don't have access to a more powerful model, at least use a different model to check this.
Gotcha. If somebody were interested in the conversation history, how do they access the storage, like the memory portion of it?
Yeah, that's a great question. I have more diagrams here that I can dig more into the actual memory part. We have short-term memory and long-term memory. The short-term memory usually is this conversation thread you ask about, usually past messages from
The thread
a
ID, the
conversation.
one.
It is called the working memory, where we, using a thread ID, we can retrieve from MongoDB a list of messages. So using a NoSQL database is very easy to just throw in, to store, to cache basically this conversation. And whenever the user joins again, like the application, or jumps in between different thread IDs, it can retrieve the conversation. This is very similar to like other applications where you have multiple conversations. Basically, every conversation is a different tradie, a different agent, or whatever. So whenever I jump between different conversations, they have like a different thread ID that keeps track of all of this. And when I open my application, I want it to like pull all those memories right back into my application. And that's why we need a real database to store this, even if it's called short-term memory. Next, we have long-term memory, which can be split in three big buckets. The most common one is semantic memory, usually used for RAG. We are using a vector database graph database or even a NoSQL or SQL database. We store factual data about our application. In our use case, we stored data about philosophers scraped from Wikipedia and similar sites. We processed them. So, for example, we cleaned this data, we normalized it, we chunked it, we embedded it, and we stored it into MongoDB under a vector index. Whenever we ask a question, the agent has like a retrieval tool which gives us access to this semantic memory, to basically to MongoDB, to query the vector index. The agent can decide, whenever user asks questions, can decide like, okay, do I know this information or do I need it to retrieve it from my long-term memory and then answer the question. So basically, it's up to the agent to decide if it needs to use this retrieval tool to access the semantic memory, retrieve it, and give an answer based on that, or just on its internal knowledge. So this is like, do I think before I speak, or just
Yeah, gotcha.
I just
Oh, just say it.
babble? Yeah, exactly.
So MongoDB is what you used for both short-term and long-term memory in your PhiloAgents game?
Yeah, exactly. So MongoDB is like a document database which provides you multiple options on how to store your data.
I see.
So you can store your data as documents, which are like JSON-like format, and you can attach to them different indexes on how you can query, access the data. A vector database offers you a vector index where you have these embeddings or theory to find similar items from your database, or you can use it as a NoSQL database. And going with a single database makes your life easier because you don't have to manage multiple databases. But modern vector databases like Quadrant, BV8, or Pinecone offer you more. Like they're more a service. For example, they also compute the embeddings on the database side. They have fancy algorithms specialized for this. With MongoDB, you have more of like a Swiss knife that is like a jack of all trades. You can get far with it, but it doesn't have like all the fancy stuff. And if you go just with a vector DB, is highly specialized into that, and it can offer you more into that way. So yeah, there are trade-offs when you pick your specific tooling. So besides this semantic memory, which is like most popular because many people heard about RAG, vector DBs, how to populate. As a final thought, you can implement it with graph DBs, normal SQL databases, or basically anything that makes sense on how you want to store your factual data and how the agent can retrieve it. Not only vector DBs make sense, graph databases are a powerful tool, but we don't have time to dig into that. We have episodic memory where we take short-term memory. We take things from short-term memory and put them in the long-term memory. That's where we store ideas or past memories from our conversations with people, right? We store their preferences, what they did in the past, what they learned, all of this. We process it into something that makes more sense for our semantic memory, like a summary, or extracting core entities, like extracting just, I don't know, where a person learned, where a person ate, where it was born, like instead
Word by
those
word, the
core
conversation. Gotcha.
Exactly. Or make it available under different methods, as I said, as a vector DB, grab it and treat it as factual data with everything that makes sense. And the last piece, like our muscle memory, similar to us, is procedural memory, like the prompt or the code itself. That's also a type of memory, because in the prompt, we tell the agent it should behave in a specific way, right? These are very hard-coded elements that are programmed by the engineer. These are the three big types of memory you will work with. Usually with procedural memory, you use it all the time. Short-term memory, you use it all the time. Semantic memory, not really, but you usually use it. Episodic memory, this is the more fancy one, where sometimes you need it, especially to make things personalized. But in many use cases, most of them, you don't need it. For example, support chatbots. You don't really care about making it personalized.
Oh, wow. Okay, wait, that's so cool. I just learned about the 4 main types of memory from you related to AI agents. So we learned about short-term and semantic memory. It's kind of like the longer-term memory. Then there's procedural versus episodic memory. Procedural memory is like the LLMs that you prompt more of like the prompt memory, right? In our architecture with neural maze, PhiloAgents don't have episodic memory because we don't pass from one LLM and summarize and then,
We could do it. So
but we
basically,
don't
like
have
Web
it now.
8, we don't have it now. I see it more like a more fancy stuff, fancy implement. It's not hard, but I wanted to keep the course beginner friendly.
If we were
It is.
to add episodic memory, where in this architecture would it fall?
Yeah, you will take this sort of memory and
Yeah.
create a new pipeline that runs every 1 minute, 5 minutes over the night and
Oh.
add it into the semantic memory. This is what happens when we create the episodic memory. We have these processes that run and create. Takes your short-term memory and adds it to your processes it and add it to your long-term memory. That's why it's called episodic memory. I think it's the name is inspired from how our biological memory works.
Wow, this is so interesting because I've always wondered how we give AI agents memory. You just explained there are 4 types of memory that AI agents interact with. My question is for beginners, can you explain the concept of RAG again?
So as I said, at the very high level for RAG, usually you want to get factual data from sources like Wikipedia in our use case or other sites, process it using this very standard but very custom at the same time strategy where you clean the data, you chunk it, you embed it and put it into a vector DB, which is called our semantic memory. But this is like the RAG pipeline that takes this data, processes it like this and adds it to the vector database. This is how we populate the semantic memory. It's also called the ingestion step. On the RAG retrieval side, on the RAG inference layer, and we access the semantic memory with a retrieval tool. And basically there we take the question of the user or past elements from the conversation, embed it into a vector, creating a vector out of the conversation. And then using the query vector, which holds what we are interested in, we query the vector database that holds factual data. The query vector and vector indexes represent the vector representation of the factual data. We do this cosine similarity, which checks what vectors are most similar to the query vector. We compute the distance between the query vector and the vectors from the database and retrieve like the closest
Similar.
vectors from the most similar ones. This is called semantic search. Of course, there's some like algorithms and techniques to make this faster and not compare your query vector with everything. Conceptually, this is the easiest way to see it.
So RAG is kind of like semantic search, but not quite, right? It's just another technique, maybe?
Yeah, semantic search is a subset of RAG. RAG stands for like retrieval augmented generation, and the concept is simple. We retrieve stuff from the outer world and put it into the prompt before we pass it to the LLM, right? We retrieve information from the outer world and pass it into the prompt that goes into the LLM. You can do RAG manually when you chat with ChatGPT or Gemini and enter articles, summarize or whatever. That's like the easiest form of RAG. But when you want to create this semantic memory and more complex systems, the trickiest part is how you retrieve the data that you care about, like from a huge database that has many documents, how you retrieve only the documents that you want to add into the prompt and pass it to the how you read the most relevant documents or memories or whatever that you want to pass to the that's the trickiest part. So that's why manual RAG is sometimes the best, because you as a human can retrieve the most relevant and put it in there, but automating this retrieval part is the complicated part of RAG.
People also talked about CAG, right? Like, have you heard of CAG before?
Oh yeah, that's also a very simple concept where you take some documents, add them. Let's say you have 10 documents you always use as context, you cache them, and you always chat against those
The
documents.
caches, yeah.
And if your set of documents is small, CAG is the way to go, because basically you skip this retrieval step and having vector databases and all this hassle. You just take all your documents, cache them using different techniques that your LLM provides, using heavy caches, usually some sort of heavy cache, and you just chat against that. Whenever you ask new questions, Those documents are in the internal memory of the LLM, like in your past conversation. Basically, the short-term memory, very easily put without going into the details. All those documents are already in your working short-term memory, and you can just chat with them.
Gotcha. So in our system with the PhiloAgents, you have the agentic RAG layer, right? So
I call it agentic RAG layer because we have this retrieval tool. Agent decide if it needs to use the tool to access the memory, or it can just answer based on its internal knowledge,
yeah,
short-term memory.
I see. So for people who are beginners, if they don't want to implement all of these themselves in the code, like they don't want to deal with all these database and RAG, CAG, is there a tool that they could just use that would allow them to just make things so much simpler? Is Mem0 the solution or
No, still need to code for Mem0, and probably you'd still need like to connect it to a database and all of this. And from what I know, it doesn't provide the agent part of it. Usually, if you want to avoid coding, there are these like no code tools like LangFuse. I think it's called LangFuse or LangFlow. There are too many. LangFlow.
okay,
LangFuse is another tool, similar topic. LangFlow is a no-code agent tool. Let me open it here. Yeah,
Langflow?
basically,
Okay.
it's a no-code thingy where you can just like drag and drop things and connect them and create all sorts of things. But the thing is with these no-code tools, they're good
But they have a lot of
for people who,
limitation.
yeah, like for example, for me, I can code this, like I just feel like I'm wasting my time with this.
I see.
I
Gotcha.
tried them, like I was excited in the beginning, like so cool. But when I dig into, for example, I wanted to connect my Notion to an LLM using this, and I saw that how limited they are, because they are very limited into how they interpret, how
Yeah.
they pre-process the Notion data and make it accessible to it.
Yeah.
This also applies to many out of the box connectors like MCP
And
Notion connectors and all of this. I also think that are like cool for doing a proof of concept, but when you want it very custom and professional for your specific product, they usually don't work and you need to write everything from scratch.
I see. So what about NAN and Make? Can't you just use some automation tool like that to collect data about a person and then maybe using it to pass it along and connecting it to the database? Can you just do that?
Yeah, I think it's fine, but I would use it for like if you want to move stuff from a Google Drive to Notion or these type of things, or
But
stuff
not
like
not
this.
do something like that.
Yeah, no, because ultimately, like for example, this RAG logic, you need to implement it yourself or connect it to MongoDB. To be honest, I haven't tried it for this use case. Maybe it worked, but I use my own tool because
Yeah.
I'm an engineer. The easiest
Yeah.
for me is just to code it.
To architect. This is super interesting because I'm learning so much from you about different types of memory. While we were chatting, you talked about MongoDB, about OPIC, Grok, FastAPI, and WebSockets. We learned a lot about tools from you. If you use OPIC and the AI agents give you a bad answer, what's usually the likely cause that something is not working quite right?
A very common issue in this exact architecture is the LLMs wants to answer without using the retrieval tool to check for factual data.
Can they do that? Can't you specify that they have to check every time or no?
You can, but I actually did. But the thing is that this, because we use English, things can get vague. How can it decide every time the user asks for factual data to use the tool? Like, what's factual data? How do you define that?
Oh, that makes
And yes, you can fix this with prompt engineering, but sometimes you need to go very deep into your subconscious thinking and articulate it into prompts. We make many decisions without thinking because we are used to it. We need to dig into that and put it into words, into prompts. I think that's the most interesting part with this prompt engineering, because like we need to dig a lot into our thinking processes and put that in English into system prompts. And even more confusing is that sometimes it works, sometimes it doesn't for the same inputs. So it's very hard to debug this stuff, and there are many failure points. That's why it's important to have tracks. Let me show you a more complicated project I'm working on now. Here is how a call looks like.
My goodness.
So yeah,
What
that's what
project
I
is
showed you
this? Is this your new book, a new course?
Yeah, it's actually on based on my new course. So this is what will people expect. I'm really trying to do something real here, But that's why you need this, because there are so many moving pieces. It can be from the prompt, it can be from the context that you retrieve, from the user input, from the LLM itself. You're not using the specific version that you're expecting, but you think you're using some decisions that happened inside the agent. And that's why you need those tools.
I see. What are some common mistakes beginners make when building AI agents like this?
They start with the agents. That's the biggest mistake.
Oh, really? What should they start with thinking?
Workflows. There are two big architectural decisions that you can make: agents versus workflows. Workflows is basically you glue the decision making, you program the decision making yourself. For example, when you want to process stuff from, I don't know, Slack to, I don't know, let me give a better example. If you want to summarize conversations from interviews, instead of letting an agent loose and just give it a task, summarize the conversations from my interviews, you can like create a workflow where you exactly know what you want from it. So you get the conversation, extract key points, quick questions, make summaries for those specific questions, and then you create a global summary. And basically here you think the process, the steps, the core steps
Through.
and you just use the LLMs to process the text, data, or images, and so on and so forth. I would always go with LLM workflows, more controllable, they're more deterministic, they're usually more cost effective, and in most use cases, they get the job done.
Do you have a framework for workflows?
Yeah, you can use LangGraph. Usually, AI agents frameworks are also LLM workflows frameworks. There's no black and white here. You usually do a combination of both. Or you can have like a 90% workflow where you use something small, more gent, like a specific step from your workflow can be an agent with some one or two tools, for example, to render diagrams, create images. If it thinks it needs to create an image and not create an image every time. Only if the user asks, it can call like an image generation tool and put it there and things like this. So that's why LM workflows and agent frameworks are always, they kind of come, maybe not always, but usually come bundled together. Yeah.
Gotcha. So what you recommend is for beginner to start with LLM workflows, think through the whole workflow first before giving a giant prompt to the agent.
Yeah, exactly. You can practice more and understand why you need an agent. Because most of the time, if you just take a pre-built agent from whatever framework you're using and you just hook it to a system prompt and tools, you don't really learn much, I would say. Maybe it gets the job done sometimes, but learning wise, it's a black box. And if you want to start connecting more pieces together and actually making something more production level, industry level, where you want it to make it more deterministic, where you want to estimate some costs, some latency requirements, and all of these that actually happens in real life, if you have zero control and you don't know what's happening behind the scenes, good luck.
I think we need training for workflows. Do you have resources for people learning to improve on LLM workflow or courses on how to do that better?
To some extent, I have another course on my GitHub.
An open source course?
Yeah.
Another free course?
I have a better place to find these courses. So I have on my page this free courses page where I have like 5 free courses. All of them are on AI engineering, maybe not AI agents per se. They take you around the AI engineering journey. Also the PhiloAgents course. I also have the only RAG related course. The second brain AI system course, which is more hardcore. It goes through everything from data engineering, collecting data, to RAG, fine-tuning, building an AI agent, building observability pipeline, to deploying open source LLM. And the ingestion part, you can build workflows where you take raw input and process it into a specific output. We don't have a user-facing workflow, but we have a workflow that builds the memory using some more fancy techniques using LLMs. And also we have this LM twin course and our personalized recommender system course. And all of these are free, really.
And all of these are learned by doing, right?
Yeah, exactly.
Also, I saw that you had a course that you were selling, but it was sold out within 1 hour or something like that.
Yeah, 24 hours or so. Yeah, I'm actually working on a paid course this time, which will tackle the LLM workflow, AI agents world, and everything will be very specialized. Code, written lessons, video lessons, notebooks, theory, practice, everything. It will be like a big, very professional course that has everything, but it will be done in like 2-3 months.
Keep us posted on when that gets released.
I will.
How do you keep up to date with the AI world? Like every day, new things are coming up.
Well, that's a tricky question. I work on so many things. I don't really have time to keep track of the latest advancements. And I created a very like more active rather than reactive system where I have like 2-3 projects that I'm working on, and I like research the latest stuff only for what I need to build. I do research every day. I read a lot. I test a lot of things, but I do that only for things that I need now, usually. And I
Just
also
in
have
time
like,
tools.
otherwise, I don't really have time. When I do find sometimes, I try to, instead of focusing on the latest stuff, I focus on fundamentals. Start with the theories, understand core concepts, core algorithms, core system designs, what are the core programming languages, how to deploy stuff. Depending on what you want to learn, understand the fundamentals of the domain, focus on that rather than the latest things. For the latest things, you need them to be competitive, but research them only when you need them. Otherwise, it's a losing game. There are 1 million fields and things going on. You cannot be receptive to everything, to the whole collective knowledge. And that's why when you need to build a specific thing, you research that. And the thing is, if you have solid fundamental knowledge, you can pick up concepts on the go.
Yeah.
That's the key, to create an environment where you can pick up everything on the go.
So, do you create your environment so it's best for you? How did you manage to do that? What do you do to your environment?
I like this question. I work from home. For me, it's very easy. I have a standing desk. So whenever I feel like I'm tired, I can just stay on my feet and it helps you get focused. I also have a very good ergonomic chair. I like to listen to productivity music designed for focusing. I put my earbuds on my ear and basically like disconnect from everything else and get in the zone.
Yeah.
So yeah. And recently I tried active learning where you say, okay, now for 2 hours I will do this. So I don't know, for 2 hours I will stay and code this specific feature. And like this, you can stay really focused. Okay, I don't care about anything else. So I won't let my mind wander and focus on this. I guess in this ADHD world we're living today, having a way to stay focused for 1.5, 2 hours is the hardest.
No, really, I agree. I'm very interested in how you do it because you work for a company in San Francisco, you have a course out, regularly post new content, partner with people, share on LinkedIn. That seems like a lot of work. I just don't know how you do it. What's your schedule like every day? How do you make time for everything?
It's hard to make time for everything. Usually all of this is aligned on a single niche, engineering. So basically I can reuse stuff from my work, the company, LinkedIn articles, and my course. All of this is the same information used in different ways. It's like the same front with different perspectives. Otherwise, I wouldn't have time. I tried, but it's impossible to also stay competitive. And like this, basically, I'm really good in what I do. And all of those fronts help me even get better into this specialized thing because I do this all day long.
I see.
And also delegation. I'm transparent about this. Delegate part of my work. I collaborate with many people. I don't have to do everything myself. And hard work, you know.
Hard. You just gotta
It's
work
all about
hard.
hard work.
Cool. Well, thank you so much for the wonderful lesson on PhiloAgents as well as AI agent memory, because that was something I've always been very curious about. So thank you for that very detailed explanation. It's such a treat that you're offering all these, courses completely for free, open sourcing it everywhere. So really appreciate that, Paul. Thank you for joining us today.
Yeah, thank you for having me. Yeah, it was really fun.
Now that we've heard and learned a bit more from Paul about PhiloAgents, I'm going to show you how you can download and install PhiloAgents yourself. So you're going to go to the Neural Maze PhiloAgents course GitHub link and copy this repo URL. Open up your favorite code editor, mine's Cursor, and then select Clone Repo. Paste in the URL that you just copied, and you can click Clone from URL, then save it to the folder you want. Select as repo destination, open it up, and you're going to see all the files on the left-hand side from the repo that you just downloaded. And open up the install and usage.md instruction and then click open preview. You'll see it formatted more nicely it's more easily readable. Then you can look at the prerequisites. Some local tools that you need are like Python, Git, Docker. Make sure you have those installed. And you're also going to need some API keys from Grok, Opic, and OpenAI. So just get those keys ready. Then you're going to hit getting started, and you're just gonna, we already did the cloning part, so all you have to do is cd into this PhiloAgents API folder. So just paste it in. Make sure you're in the PhiloAgents API folder. Then you're gonna copy the installation instructions kind of word by word. I'm just following the instructions, making sure the environment is set up, and then making sure, double checking that the Python version is expected 3.11.9. And then you're gonna clone the .environment file so you can paste in the API keys. When doing this part though, I noticed that the Comet API key, I think it should be Opic API key. So I added in the Opic API key and Opic workspace, and that helped run the PhiloAgents. So that's what I did. And then you're gonna make sure you run Docker by pasting in this command. And you can also do make infrastructure -build and then make create -long-term memory. After you did all that, if you open up localhost 8080, you will see the game, happening. And then you can start chatting with Socrates and all these other Aristotle, Plato, philosopher. So I just asked, why do we die? And kind of gave some answer. And you can see that with each character, I can say I'm a different name and it will remember the name that I said. So it's like a one-on-one conversation. If you want to tweak the prompt, you can go to source/PhiloAgent/ prompts.py, and you can tweak it. And then I think there's a few other locations where you would be able to tweak the prompt. But other than that, that's it for today, and see you in the next video. Thanks. Bye.